Our third exercise, how many bit strings with length not exceeding n and non-empty consist entirely of zeros or ones? So I've told you in the previous lesson that if your exercise says to write a solution that depends on n or m or etc., then a good approach is to place a value in n, solve the exercise with this value, and then generalize your result. So if n equals 3, the exercise is how many bit strings with length not exceeding 3 and non-empty consist entirely of zeros or ones, and now it is rather easier. So I can observe here that there are three cases about the length of the string. The first case is that the length equals 1. The second case is that it equals 2, and the third case is that it equals 3. These are the three cases. Now it's very easy to solve each problem. How many strings of length 1 are there that consist entirely of zeros or ones? And the answer is that there are just two strings. It's the string 0 or the string 1. These are the two strings. And about the strings with length 2 that consist entirely of zeros and ones, there are again two strings, the string 0, 0 and the string 1, 1. And for length 3, it's the same, the string 3 zeros and the string 3 ones. Now I can generalize my solutions, so let's write it down typically. There are some cases and I leave it blank, and I will fill how many cases are there when I solve each of these cases. And I'm writing down that the length may be 1, the length also may be 2, and here I'm putting 3 dots, and then the final case is that the length is n. And here I'm writing down my solution. Here is 0 or 1. I'm writing down that there are two solutions. Again, here it is 0, 0 or 1, 1. Again, two solutions. And finally, when the length is n, there is 0, 0, 0 n times, or 1, 1, 1 n times. Again, two solutions. And here that I've written down my cases, I see now that they are n, and then I'm going to apply the rule of sum, because when I have cases, I'm applying the rule of sum. By the rule of sum, the sum of all these cases are 2 plus 2, etc. plus 2, and this goes for n times. N times, so the totality of these solutions are 2 times n.